Hey guys, welcome to Solving Logarithmic Equations. This is Unit 4, Day 2. So we're going to go through solving a couple of examples of logarithmic equations. There's basically two different types that you will see. And you'll see type 1, which are going to be the more difficult or so types, and then type 2, which are going to be quite a bit easier to solve. So when we're looking at one like this, since there's no logarithmic on the right side, it's only on the left, we have to move this to and convert to get rid of the log. So it becomes 5x plus 7 is equal to 2 to the fifth. And that's kind of an extension of what we were working on last time. So when we simplify this, we have 5x plus 7 is equal to 2 to the fifth, which is 32. I had to do some math in my head. We'll subtract 7. It becomes a pretty easy 1 to 2 step algebra problem. 5x is equal to 25, and then x would be 5. All right. Overall, that one's pretty simple, but it's a little more difficult than what we'll see down here. If we have the same log base on both sides, those just cancel out, and that's going to make it technically a two-step problem, but it's going to be pretty easy for the most part. So we have 7x plus 3 is equal to 5x plus 9. If I move that 5x over, we end up with 2x. I'm going to go ahead and subtract this 3 as well, is equal to 6, and that means x is equal to 3. All right, so when we look down here, the first thing you always have to make sure that you do is have one log on both sides if you're going to cancel out. So we wouldn't be able to just cancel all of this out and say x plus 2 plus x plus 3. It would not work because this is technically written as x minus 2, x plus 3. So even though we're adding logs, we're technically multiplying, as we learned during 4.1 when we were doing our conversions. So this is how we would end up having to write it. That's probably one mistake a lot of people would make. So we get x squared plus 3x minus 2x minus 6 is equal to 14. I'm going to move the 14 over. Then we would get x squared plus x minus 20, which actually becomes x minus 4x plus 5 equals 0. So our x values would be a positive 4 and a negative 5. Now, how to know when one will be extraneous is if we were to plug either of these x values into here. If either of these numbers is negative, then that we cannot have negative logs, and that means extraneous. So I'm actually just going to make a note of that. So negative logs will always be extraneous. So if I were to plug in 4, we'd get 4 minus 2, which is 2. That's positive. 4 plus 3 is 7, so that's good. So x equals 4 works, so we're good there. If I were to put negative 5, that would create a log base 2 of negative 7. That we cannot have. So that one will be extraneous. All right. And then we're going to work a couple more examples down here. This is another one. We will have to take the base and move it. So we end up with 2x minus 1 is equal to 5 to the third, which is 125. I'm going to move that 1 over, and that gives me 2x is equal to 126. Once we divide by 2, x is 63 here. All right, let's look at this one here. We luckily have the log 2 on both sides, so we'll just cancel that out. We have x squared minus 1 is equal to 2x squared minus 17. Okay, I am going to go ahead and move this 1 over. Actually, I'm going to move the 17. Oh, no. That's still a subtraction. once I do that, I'm also going to move the x squared over. So even though there's no x value, that would make this, like if there was just a normal singular x value, we could turn this into a polynomial like we did up here. But because we still only have an x squared and then a value, we're going to set them equal to each other and see if we can solve that way. So then we're left with 2x squared. Oh, I'm sorry, just wait. Minus, nope, just x squared is equal to oh, you know what? That was a -1. -1 plus 17. That makes, okay, sorry, 16. I was confused for no reason. So square root of x squared obviously would produce the square root of 16. And that means that our x is equal to positive and -4. Now, we still have to go back and check for extraneous solutions here. If it's positive 4, you're squaring that. 16 minus 5 is 15. Positive 4, 16 times 2 is 32. Minus 17 is going to be positive. So positive 4 is good. That also means that -4 is going to be good because we're squaring it every time. We're automatically going to make it positive, even if it is -4. So both of those will work just fine. All right. Oh. We're going to work a couple more examples, and that's going to be it on this portion of 4.2. All right, so we have log base 4 of x equals log base 4 of 3 plus log base 4 of x minus 2. Now, even though we are technically adding, when we finally combine these together, it would be log base 4 of 3 times x minus 2. Make sure that you are always doing that every time, multiplying when you're adding. So then we can go ahead and cancel these out. We have x is equal to 3x minus 6. Move that 3 over. We get -2x is equal to -6. Divide by -2. And our x is a positive 3. All right, and then let's look at this one over here. Okay, because we have a basic log on each side, we can go ahead and cancel those out. We have 2x is equal to x squared minus x plus 2. I'm just going to go ahead and move this 2x over. So we end up with x squared minus 3x plus 2. And we will be using x minus 1 and x minus 2 is equal to 0. Okay, and then here our x values will be, let's see, 1 and 2. We can always check to make sure that they will both produce positive values. Over here, they would both produce positive, and then we have 1 squared minus 1 is 0 plus 2. 2 squared is 4 minus 2 is 2 plus 2. So they will both produce positive logs. Therefore, they are both going to work. All right, we've got 2 more that we're going to look at. Okay, the first thing that we're going to do on E is combine the logs that we have on the right side. So because it's subtraction, we will be writing them as division. We have x over x plus 3 equals 5. Okay, from here, we do what we've been doing when we have this situation. We're going to move this 2 and put it to the 5th power. Is equal to x over x plus 3. From here, we will convert that. 32 is equal to x over x plus 3. We have to multiply both sides by x plus 3, in which case I would multiply this side by x plus 3. And that would give me a 32x plus 96 is equal to x. All right, and then from here, I'm going to move that 32x over. And that would give me 96 is equal to negative 31x. Even if I were to divide by negative 31, we won't get a whole number here, so I'm actually just going to leave it as negative 96 over 31. If I were to take this is approximately something a little more than 3, probably like 3.2, negative 3.2. We could say it's somewhere around there. If I were to take this negative 3.2, it would create a negative log here, and it would also create a negative log here. Therefore, it's extraneous. All right, and then our last one here. So we have 1/2 log 3 to x plus 1. 1/2 log 3x minus 4 is equal to log 3 of x, 6. So before we can cancel out all these log 3's, we have to combine the two that are on the left side. All right, so the 1/2 is actually the same as x plus 1 to the 1/2. This 1/2 actually represents the exponent like this. All right, this is just a fancy way of writing this. So this would be square root of x plus 1, and we also have it here, so it'll be square root of x minus 4. So I'm going to go ahead and combine those into square root. And let's say I still had the log 3 of 6. We can go ahead and cancel those out now. So I will square both sides to get rid of that. So we have x plus 1 times x minus 4 is equal to 36, which produces x squared minus 4x plus x minus 4, which gives me x squared minus 3x minus 4 is equal to 36 still. So I'm going to move that 36 over to this side. And that gives me x squared minus 3x minus 40. And we can use 8 and 5. Looks like it'd be x minus 8, x plus 5. So our x values are equal to 8 and negative 5. Okay, if I were to plug both of those back in, 8 over here, 8 plus 1 is 9, so that's positive. 8 minus 4 is 4, so that's positive. So x plus 8 is good, or x equals 8 is good. If we were to have negative 5 plus 1, that'd be negative 4. And then negative 5 minus 4 is negative 9. So negative 5 is extraneous. But x equals 8 works for us. And that is solving logarithms.